So we're going to start our chapters with Chapter 1, and Chapter 1 is about remembering general chemistry, electronic structure, and bonding. And these are things that you should know from Gen Chem 1 and Gen Chem 2. And you're expected to be able to perform these tasks even without having gone through the chapter material. So this should be completely review and things that you know. You're going to need to really be able to draw Lewis structures from day one in this class. Draw Lewis structures, build Lewis structures with the model, understanding how many bonds an atom can have, how many bonds an atom prefers, etc. So if you're not comfortable with drawing and building yet, then you need to start practicing now. Organic chemistry, this course is going to be the study of organic compounds and reactions that organic compounds undergo to create other organic compounds. And organic compounds, why do we call them organic? These compounds, carbon is a molecule derived from living organisms. And so these are considered organic, just means with a vital force. So something that has been evolved from a living organism, and inorganic compounds come from minerals, from rocks, from ores, and these are usually compounds containing metals or crystals containing metals. So the compound that they put here is ammonium cyanate, which is an inorganic mineral. That is because the ammonia does not contain a bond to carbon. It's only nitrogen and hydrogen, and that's one ion. And then the cyanate is the OCN molecule, OCN minus. There we go. This one here, this is the cyanate anion, and it has carbon and oxygen and nitrogen, and so I would actually consider that to be an organic ion. But the molecule as a total, an ionic compound, is an inorganic compound, and this is found in mineral sources, and so it's not necessarily being derived from life. But if you take this mineral and you heat it, then you achieve an organic compound called urea, which is a product produced by living organisms. And organic compounds, these are what we call organic compounds in general, are compounds that contain carbon, and so when you think of organic chemistry, you should think about the study of carbon compounds. The structure of an atom. This is something that I expect everybody knows. We don't really need to go through it. We're just going to be really quick. We know that an atom is a substance with a small, dense nucleus that is positively charged and containing protons and neutrons. Protons and neutrons have mass. These small, dense nucleus is surrounded by a cloud of electrons that are distantly spaced, but that are negatively charged and therefore attracted to the nucleus. The atomic number of an atom is based on the number of protons. The number of protons does not change. The number of neutrons can vary from isotope, and the number of electrons can change. Okay, so if an atom has an atomic number of 7, that anything with 7 protons is always going to have that symbol or identity on the periodic table. So carbon has an atomic number of 6. It will always, if you were given that you have that their request, if they give you the atomic number, you should be able to identify what atom it is on the periodic chart. A neutral carbon compound is going to have 6 protons and 6 electrons. So 6 positive charges and 6 negative charges will equal to a 0 charge. So there's always that. So when electrons and protons are equal, there's no charge. Why is carbon so special? Why are living organisms carbon-based organisms? That is because carbon shares electrons. So let's look at this. This is the first row of the periodic table. These elements represent the first row of the periodic table. It's not. Ha 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 ha. Okay. I'm going to get the pen working. Here we go. So we have lithium, which has atomic number 3 and 1 valence electron. It's in group 1, therefore it has 1 valence electron. Now I need the eraser. Okay. So let's put atomic number at top, A number, and valence, V, valence on the bottom. So lithium atomic number 3 and valence 1. Beryllium atomic number 4, valence 2. So lithium is in group 1, beryllium is in group 2, boron is in group 3, has atomic number 5 and valence of 3. Carbon has atomic number 6, valence of 4. Nitrogen atomic number 7, valence of 8. Oxygen atomic number 8, valence. Oh, yeah, sometimes I say things that are weird. Let's go back. Nitrogen atomic number 7, valence of 5. Oxygen atomic number 8, valence 6. Fluorine atomic number 9, valence 7. So notice that the valence number also corresponds to the group number on the periodic table. And you should all know that the ideal number of electrons for the or the ideal state of an atom is to be like a noble gas that has a full valence shell. So an atom either loses or gains electrons in order to have a full shell. If it loses if it's in row 2 and it loses electrons, then it will become like the noble gas in row 1 and have a full shell when it has 2 electrons. If it is in row 2 but is closer to having a full shell when it has 8 electrons, then it will become like the noble gas at the end of row 2. So for all of the atoms in row 2, they either have to lose electrons until they have 2 to be like helium, or gain electrons until they have a valence shell that has 8 electrons and be like neon. So lithium has 1 valence electron. It can either gain 7 electrons to become like neon, or it can lose 1 electron to become like helium. So we can write that down on the slide. I'm going to change color. We'll put gain 1, or sorry, that's not correct. Gain 7. It's really frustrating that I can't just switch to eraser. Okay. So for valence, and then for gaining electrons, if we gain 7, gain 6, gain 5, gain 4, gain 3, gain 2, gain 1, then we can become like neon. The other option is to lose electrons. So if we lose 1, 2, 3, 4, 5, 6, 7 electrons, then we can become like helium. So what actually happens is whatever is easiest. Is it easier to gain 7 electrons or to lose 1? Well, it's easier to lose 1. So lithium is going to lose 1. Beryllium, is it easier to gain 6 or to lose 2? Lose 2. So that's what happens. In boron, we can gain 5 or lose 3. It loses 3. When we get to carbon, there's equal chance. We can gain 4 or we can lose 4. Neither is ideal. There is no preference. So what carbon does, instead of gaining or losing, is it shares electrons with other atoms. With nitrogen, it can gain 3 electrons or lose 5. Gaining 3 is easier. Oxygen, gain 2 or lose 6. Gaining 2 is easier. And fluorine, gain 1 or lose 7. It's going to gain 1. So what you should notice here is that the metal atoms on the left side, they lose electrons. They become positively charged. The atoms to the far right, they gain electrons. They become negatively charged. And this is exactly something you already learned in Gen Chem, that positively charged ions tend to be metals and negatively charged ions tend to be non-metals. And atoms to the, so that's what the slide is saying. Atoms to the left of carbon give up electrons. Atoms to the right of carbon accept electrons, but carbon shares electrons.